Here we have a problem where we have 9 non-distinct numbers and we want to know which of the following cannot affect the median. The median, remember, is the midpoint. Half the values are greater than it, half the values are less than it. For instance, if we had 95, 94, 94, 93, 22, 21, and 3, 93 would be our median. That would be our midpoint. Half the values are above it, half the values are below it. Now, which of the following cannot affect the median? That tells us we want to look at the answer choices and see what would affect the median. Actually, if you look at A, that's one of the hardest ones to reason, because squaring each number logically tells us shouldn't affect the median's place. However, if we have a number where we are involved with 1, and hence it doesn't move when it gets squared, or we're dealing with fractions, then we have a situation where we could change the order of the numbers when we square them. So that could have an impact on the median. If we increase every other number by 5, of course that could change that, because if there's a number less than 5 away from the median, that would have an impact. Increasing the smallest number only. Yeah, as our case where we had 95, 94, 94, 93, 22, 21, and 3, if we increase 3 by 100, that changes the median. Increasing the largest number only. Increasing the largest number only isn't going to change that median. It's already the largest. So if we increase it, we just make it bigger. Decreasing the largest number only, yeah, logically, we could take that 95 and subtract 100 from it. That would change the median. So our answer is D. Let's also take a chance here to point out that the mode of these numbers, the most frequent or common score, would be 94, because there are two 94s there. Here we have a median question where we want to know, in a certain chemistry class, if the median score was 84, which of the following must be true? It absolutely has to be true. Remember, with the median, half the values are above it and half the values are below it. So in this case, looking at our answer choices, the highest score in the class is at least 1 point higher than the lowest score. No, that's not necessarily true. Technically, the median could be the midpoint if we had all the numbers be the same, then the median is that number. If everybody scored 84, your median would be 84. If there was a score of 83, there was also a score of 85. Well, that's indicating that you've got 83 and 85, and those are the only test scores. Again, it doesn't have to be true. The mode, okay, the mode is the most frequent score. The mode of the test scores was 84. No, that doesn't necessarily have to be true, because 84 could only happen one time, or in fact 84 could be the average of two numbers and represent the median that way. So that doesn't have to be true, and our answer choice then is E. This is a pretty convoluted problem, and yet it's not that hard to do. We've got to get the numbers out of the words so that it makes sense. It says x, y, and z represent three positive integers where x equals y plus x and y equals w plus 20. What's the result when the average of these numbers is subtracted from the median? Okay, let's look at this. We've got to find out which one is the median. Well, if x equals y plus 5, x is greater than y. And if y equals w plus 20, y is greater than w. So x is greater than y, and y is greater than w. That means y is our median. And we want to subtract the average from the median. So we're going to have y minus x plus y plus w over 3. We want everything in terms of y, so we're going to have to substitute a value in terms of y for x and for w. Well, x equals y plus 5, so I can substitute y plus 5 in there, right? And in this case, I've got y equals w plus 20, w would then be y minus 20. So I can substitute y minus 20 in there for w. So once I've made the substitution, I have y minus, I've got 3 y's up there, so that would be 3y, and plus 5 minus 20 would be minus 15. So I have y minus 3y minus 15 over 3. Remember, when you have a split numerator, that denominator applies to both. So 3y over 3 would be equal to y, and negative 15 over 3 would be negative 5. So I have y minus 5. Distributing that negative across, I have y minus y plus 5. So the result, when I subtract the average from the median, is 5.